Welcome to Curie Electronics. So this microcontroller applications, today we are going to learn how to interface switch with an 8051 microcontroller. Already we have seen how to interface LED with the 8051, that is we are using AT89C52 microcontroller. And after this, next video is going to be about the interrupt, how to use the external interrupt, that I'll show you in next video. So this video we are going to see how to interface switch with LED. If you have seen the first video, then this video is going to be very easy for you. So in the first video we have seen this circuit, that is we have connected a LED and we wrote the code for blinking LED. Today I'll make slight changes to this circuit and connect one switch to it. So I have removed this switch from here. It is not required because we need only the power on reset. In between I am not doing the reset. And this switch before that what I have done, this LED I have reversed. To show you, you can connect the LED in both the ways. See, this resistor you can put around 470 ohms or 330 ohm, whatever in range in between or whatever values you have. Now to turn on this LED, what we have to give here from the port 2.0, you have to give a low. When you give low, one more something also we have to change. What about this cathode? This cathode should be connected to a 5 volt supply. So this will go to 5 volt. That is the VCC for our microcontroller. Now to connect the switch we need one more port. So for that what I have done, I have taken port 2.4, P2.4. I have taken port 2.4 because it is the 25th pin. Easily I can find out in the breadboard. That's how I have placed the microcontroller. Now after that what you have to do, we have to connect the switch. So I have used a push to on switch. Okay, so when I press the push to on switch on here, when I press, the switch will make the contact and this goes to ground. But we have to give a pull up to the switch. It should not float. So I have connected one resistor to 5 volt, that is a 4.7k resistor, 2 kilo ohm resistor to pull up. So when the switch is open, the port 2.4 will get high input, so that we can identify that the switch is not pressed. When switch is pressed, it connects to ground and the port pin goes to low. Now let's see how to write the code for this. Now what you have to do, first you have to include our register 52 register. That is the microcontroller we have to hash include. Later on I won't tell you these steps. Hash include register 52.h. This file we have to, this header file we have to include. And then we need 2 microcontroller pins. So we have to define 2 pins where we are going to connect this LED and the switch. That is S bit LED. LED I am going to connect port to 0, P to 0. And then What about the switch? Switch also I need one more S bit variable. S bit switch. S bit switch equal to port to fourth pin. I have connected port to fourth pin. Now what we need? We need one main loop for the void main. We are not returning anything. So I'll write void main. After void main, what you want? You want two curly braces. Okay. Now what we need? What is the, when the program initializes, what is the value of LED? LED equal to 1. It means what? Now LED is off. Also, switch equals to 1. If we don't write this switch equal to 1 also, it is going to be 1 only, because we have a pull-up resistor there. So switch also off, not pressed. I'll write not pressed, not activated, or in simple language, not pressed. Now we need an infinite loop. So I'll write while 1. For loop also you can use. While 1, what I'll do? This is the while loop curly braces. So here I'll write if switch equal to 0. Equal to 0 means if switch is pressed, then LED should be on. For that, LED has to be 0. Else LED will be off. I am not writing here. That you could see in the code. And see, when you use the if loop here, if there are a number of lines of code, then you have to put a curly braces. Now only one line of code is there with the if condition, then you have to use, you know how to use the curly braces. If more than one line of codes are there, then you have to use the curly braces. Now what we'll do, as usual, we'll write the code, then we will construct it in a breadboard and check the working of it. Now let's see how to write the code for it. So I am having Microvision 3. You can use any versions of this. So just double click on the Microvision key, so it will open up. Now go to project. This, let me close it. Now go to project, new Microvision project. So we have to create take one folder, switch and LED. Sorry, SW. Switch and LED. Okay. Then give a same name. I will give it, switch and LED. We are going to interface switch and LED to the microcontroller. Save. Now which device we are using? I am using Atmel 89C52. 89C52. See, when you select the IC or microcontroller, it shows what is the RAM, what frequency you can run it, or ROM, everything it shows. Give OK. No. Now what you have to do? Just we need a file. Click here, and we have to write the code here. I already wrote the code, so I'll just copy it. See, after copying it, you have to, or after writing the code, just save it. This also I'll write it as SW_LED. It is a .c file. .c. SW_LED.c. Now I have saved. Now don't forget to add this code file to the source group. So what you have to do? Click on this plus sign here, right click on the source, add files to group, source group 1. Select it. Now it's added. Now if we come and click here, it shows here. Then only it works, okay? And one more thing you have to understand, go to projects, options for target 1. And here the output, you see here the output. There the create hex file has to be selected. Otherwise you won't get the hex file to upload. In this video I won't show how I am uploading the hex file. You can use any programmer to upload the hex file. The previous video I have shown you. Now okay. Now let's compile the project. For that, see here, you have to build target. Click here. So it is showing here switch and LED, 0 errors, 0 warnings. So our program is syntactically correct. It means no syntax error, but logically may or may not be correct. Now what you have to do, you have to run the debug. You can simply run it. Go for debug option. Debug is running. Our port 2, to the port 2 we are connecting LED and the switch, correct? So we need port 2 to see that. Peripherals, go to peripherals, IO port 2. Now we'll just run or debug the program and see. Clicks here, see here, you can see step over, step into, like that, various options. So now when I step over, see, the program is running. Now switch was not activated. Now what I will do, switch is connected to port to 4th pin. 1, 0, 1, 2, 3, 4th pin. I have made that pin low. Now let's run it. Step over. See, it has gone in. Now switch is equal to 0. Sorry. And the program has gone to the inside the if condition. Delay is for the debouncing of the switch. So now you see LED turned, LED, that port pin where LED is connected, that port pin has become 0. Now LED is on because cathode is connected to the port pin. Now we are keeping the switch pressed. It is going to stay in if condition itself. So the LED is going to be on. Switch is pressed and LED is on. Now let's make the pin high. We have released the switch. Then what happens? See, LED is equal to on. Here port pin is high. That means LED is off. So that's how this program works. Now what I'll do, I'll upload the code on the microcontroller and I will show you it's working. So this is the breadboard setup, reset circuit and the oscillator just as the previous video. And here what I have extra added, one switch I have added, this is to the port to 4th pin, that is the 25th pin of the microcontroller. And there I have used a pull-up resistor to the switch, that is here. It is connected to through a 4.7K resistor is connected to VCC, that is 5 volt of the microcontroller. And for the LED to the 21st pin, I have connected 100 ohm resistor. You can use 100 ohm to 470 ohm resistor in between any value. That resistor, one end is connected to the 21st pin, that's the port to 0 pin, and the other end is connected to the VCC. Now I am going to press the switch. It's a red LED, but I am not able to capture it properly. So let's see. Let me press the switch now. See, when I press, the light is getting on. When I release, it is off. Now again, if I press, it is on. So I hope you understood how to write this basic program and run it. The next video, what we will learn about the interrupt. How to write an interrupt subroutine and make use of the microcontroller interrupt function. Thanks for watching.